Hello and welcome to this Safety Learning Podcast. Today's episode focuses on the PanAust Group Underground Ground Control Safety Standard. This standard is critical for anyone working underground, including employees, contractors, and visitors. By the end of this session, you will understand why ground control is so important, learn how PanAust manages underground geotechnical risks, build confidence with technical English vocabulary used in the standard. Let's begin.
Purpose of the standard. The purpose of this safety standard is simple but essential: to prevent injuries, fatalities, and damage to mine assets caused by unstable ground. Underground mining involves natural hazards such as weak rock, faults and fractures, groundwater, stress changes caused by excavation. This standard ensures that these geotechnical and hydrogeological hazards are identified, assessed, controlled, and monitored. All work must be done systematically and under the supervision of geotechnically competent personnel.
Who does this standard apply to? This standard applies to employees, contractors and subcontractors, and visitors. Anyone performing controlled activities underground at a PanAust site must follow this standard. Important note: this document applies only to underground operations, not surface mining. Surface hazards are managed under a separate safety standard.
Key objectives. The standard sets clear objectives to reduce ground control risks, including having a ground control management system, collecting and managing geotechnical data, ensuring qualified personnel control ground-related decisions, conducting investigations before excavation, using engineering analysis to design safe excavations, maintaining and commissioning ground control equipment, training all underground workers to be competent and fit for work.
Performance criteria: how safety is achieved. Let's break this into practical steps. Risk assessment. Risk assessments must be carried out at every stage of underground work in accordance with PanAust risk management systems. This helps identify where ground may fail, who could be exposed, and what controls are required.
Geotechnical data collection. Qualified personnel collect important data such as rock strength, faults and joints, groundwater conditions, stress levels in the rock, seismic activity, past mining information. This data helps engineers predict how the ground will behave during mining.
Modeling and analysis. Engineers use collected data and software tools to identify failure modes, analyze stress changes, design support systems, and understand blasting and seismic impacts. This step ensures designs are evidence-based, not guesswork.
Mine design must follow a formal process involving geotechnical engineers, mine planners, geologists, and operations teams. Design considerations include pillar size and location, ground support, fill systems, and end-of-mine safety and stability.
Ground Control Management Plan. Each site must have a documented plan that includes geological background, design criteria, SOPs, support specifications, inspection and emergency procedures, and training requirements. This plan is updated throughout the life of the mine.
Ground behavior must be monitored through inspections, instrumentation, movement and seismic monitoring, and quality assurance checks. Results are used to improve designs and controls.
Equipment, maintenance, and training. Equipment must be calibrated and commissioned. Maintenance schedules must be documented, and all underground workers must receive regular ground control training. Only competent persons are authorized to manage geotechnical risks.
Conclusion. Ground control is not just engineering, it is life-critical safety. By following this standard, PanAust ensures safer underground workplaces, reduced risk of collapse or rockfall, protection of people, equipment, and infrastructure. Thank you for listening. Stay alert, stay trained, and stay safe underground.
Below is a clear vocabulary guide with simple meanings and example sentences taken directly or closely adapted from the PanAust Group Underground Ground Control Safety Standard. The example sentences reflect the original wording and intent of the document, with minor formatting for learning clarity.
1. Ground control. Simple meaning, managing and supporting rock to prevent collapse and keep people safe underground. Example from the standard. A system shall be in place that ensures the systematic management of underground geotechnical and hydrogeological risks during exploration, project planning, development, construction, and operation to closure.
2. Geotechnical. Simple meaning, related to the strength, behavior, and condition of soil and rock. Example from the standard. Qualified personnel shall coordinate the gathering of data to form geological and geotechnical databases and models for the selection of a mining method and the mine and stope design.
3. Hydrogeological. Simple meaning, related to groundwater and how water moves underground. Example from the standard. This standard defines requirements for the systematic application of validated methods to identify, measure, evaluate, manage, and monitor geotechnical and hydrogeological risks associated with underground exploration, development, and mining activities.
4. Hazard. Simple meaning, anything that can cause injury, death, or damage. Example from the standard. Geotechnical and hydrogeological hazards inherent to underground exploration, development, and mining activities are identified, evaluated, and managed in a systematic manner.
5. Risk assessment. Simple meaning, a process to identify hazards, evaluate risks, and decide how to control them. Example from the standard. Appropriate risk assessment processes shall be used for each stage of the ground control strategy and activities.
6. Competent person. Simple meaning, a trained and experienced person who can do the job safely. Example from the standard. Only competent persons working under the direction of PanAust shall be authorized to conduct activities associated with the management of underground geotechnical and hydrogeological risks.
7. Excavation. Simple meaning, any man-made hole or cavity greater than 1.5 meters deep made by cutting and removing quantities of soil or rock and requiring ground control.
Example from the standard. Definition section. Any man-made hole or cavity greater than 1.5 meters deep made by cutting and removing quantities of soil or rock and requiring ground control.
8. Rock mass. Simple meaning, all the rock underground, including cracks, faults, and groundwater. Example from the standard, define the engineering properties of the rock mass in each geotechnical domain.
9. Failure mode. Simple meaning, the way rock or ground may fail, collapse, or move. Example from the standard, identify the potential modes of failure.
10. Ground support. Simple meaning, materials like bolts, mesh, shotcrete, or cables used to hold rock in place. Example from the standard, ground support shall be used as necessary based on risk assessment and shall be designed, installed, tested, and maintained to control the ground where persons work.
11. Monitoring. Simple meaning, regular checking and measuring to see how the ground behaves. Example from the standard, monitoring the implementation of the design and the response of the ground to the mining activities and adequacy of the control measures shall be undertaken.
12. Shall or must. Simple meaning, mandatory. The action is required and not optional. Example from the standard, a system shall be in place that ensures the systematic management of underground geotechnical and hydrogeological risks during exploration, project planning, development, construction, and operation to closure.
13. Should. Simple meaning, recommended best practice, but not compulsory. Example from the standard, seismic monitoring may be conducted in areas as required by geotechnical advice and risk assessment.
14. Calibration. Simple meaning, checking equipment accuracy to make sure measurements are correct. Example from the standard, a system documented for the inspection, servicing, and calibration of all equipment used to manage geotechnical and hydrogeological risks.
15. Commissioning. Simple meaning, making sure equipment is ready and safe before use. Example from the standard. A system shall be in place that ensures receipt of underground geotechnical equipment from suppliers occurs after the provision of evidence demonstrating calibration.